Okay friends, welcome to today's video. Today we are going to look at properties of quadrilaterals. Okay, Euclidean geometry part 6 of 25. Okay, so what is a quadrilateral? A quadrilateral is a polygon having 4 sides, 4 angles and 4 vertices. Okay, and the sum of all interior angles of quadrilaterals is always 360 degrees. Okay, the sum of all interior angles of quadrilaterals is always 360 degrees. And what is a polygon? A polygon is a closed two-dimensional shape bounded by straight lines. Okay, a polygon is a closed two-dimensional shape bounded by straight lines. So a circle is not a polygon because it is not bounded by straight lines. A circle is bounded by a curve. Okay, so you understand a circle is not a polygon because it is bounded by a curve, not straight lines. So we are going to start with the properties of a kite. Okay, a kite is a quadrilateral. It's got 4 sides, 4 angles and 4 vertices. Vertices are corners. Okay, 4 sides, 4 angles and 4 vertices, the corners. Okay, a kite has got 2 pairs of adjacent sides of equal length. This side and this side, they are equal. They are adjacent. Adjacent means next to each other. This side and this side, they are equal. They are adjacent. Okay, so this side is equal to this side. This side is equal to this side. Okay, has got 2 pairs of adjacent sides of equal length. And a kite has got no pair of parallel sides. You don't have parallel side. Okay, has got no pair of parallel side. And the diagonals always intersect at 90 degrees. Okay, at 90 degrees. This diagonal and this diagonal, they intersect at 90 degrees. And a kite has got 2 diagonals of an equal length. Okay, this diagonal is not the same as this diagonal in terms of the length. Okay, this is shorter and this is longer. Okay, and angles opposite to the longer diagonal are equal. Okay, this is the longer diagonal. This angle and this angle, they are opposite to the longer diagonal, so they are equal. Okay, so this angle and this angle, they are not equal. They are opposite to the shorter diagonal. Only this angle and this angle, they are equal. Okay, so angles opposite to the longer diagonal are equal. And the kite is symmetrical about the longer diagonal. So the longer diagonal is the line of symmetry. If you fold this kite about this line, you are going to have this exactly on top of this. Okay, so let me show you. If you fold this kite about this line, you're going to have this part. Okay, exactly on top of this part. So this line is the line of symmetry. So you can say the longer diagonal is the line of symmetry of the kite. Okay, you can see that. Let's carry on. Now, the shorter diagonal forms 2 isosceles triangles. Okay, let me show you. So you have this. This is the shorter diagonal. Okay, you have this triangle And you also have this triangle. This is an isosceles triangle. This is also an isosceles triangle. An isosceles triangle has got two sides which are of equal length. Okay, this side is equal to this side. So this is an isosceles triangle. This side is equal to this side. So this is an isosceles triangle. Okay, so the shorter diagonal forms two isosceles triangles. Okay, the longer diagonal forms two congruent triangles. Okay, the longer diagonal forms two congruent triangles. Okay, you can see that using the congruence property, side, side, side. Okay, so the longer diagonal, let me show you. This is the longer diagonal. Now you have this triangle and this triangle. So using the congruence property, side, 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 this side is equal to this side is equal to this side, and they have a common side. So the two triangles are congruent by congruence property, side, side, side. Okay, let's carry on. And the longer diagonal bisects the shorter diagonal. Okay, the longer diagonal bisects the shorter diagonal. Okay, this longer diagonal bisects the shorter diagonal. To bisect means to divide into two equal parts. Okay, let me show you that. So let me get my highlighter. So this part is the same as this part. Okay, this part is the same as this part. So the longer diagonal bisects the shorter diagonal. It divides this shorter diagonal into two equal parts. Okay, you can see that. Let's carry on. And the longer diagonal bisects the pair of opposite angles. This and this. This longer diagonal bisect this angle and this angle. It means this angle is divided into two equal angles, and this angle is divided into two equal angles. This is why I have a green circle and a green circle, meaning this angle is the same as this angle. I have a black square this side and a black square this side, meaning this angle is the same as this angle. Okay, let me show you. So this angle is the same as this angle. Okay, this angle is the same as this angle. This is to bisect, to divide into two equal parts. And now the shorter diagonal does not bisect the pair of opposite angles. Okay, this short diagonal does not bisect this angle and this angle. Only this longer diagonal bisect this angle and this angle. Okay, and we have right kites. Right kites are cyclic. We are going to see the right kite in video 7 of 25 to calculate the area of a kite. Okay, the area of a kite. Let's call this diagonal D1 and the long diagonal we call it D2. So to calculate the area of a kite, you are going to have 1 over 2 times D1 times D2. Okay, let's move on to properties of a trapezium. A trapezium is also a quadrilateral. Okay, it's got 4 sides, 4 angles, and 4 corners. It's got 1 pair of parallel sides. Let me show you. This side is parallel to this side. Okay, this is 1 pair. Okay, 1 pair of parallel sides. And the parallel sides are called bases. Okay, this is a base and this is a base. Okay, the parallel sides are called bases, and a trapezium has got two diagonals of an equal length. So the length is different from this. Okay, let's carry on. A trapezium, the two diagonals intersect each other. They intersect there. Okay, so to calculate the area of a trapezium, let's call this base A, and let's call this base B, and let's have our height H. The height is always perpendicular, right? Perpendicular to this base or perpendicular to this base. Now, the area of a trapezium is equal to 1 over 2. In bracket, you have the sum of the bases times the height. Okay, now let's see the types of trapezia. You have a scalene trapezium. A scalene trapezium has got no equal sides. Okay, no equal sides. Even the angles are not equal. And you have an isosceles trapezium. An isosceles trapezium has got two equal sides. This side is equal to this side. Okay, you can see that this side is equal to this side. So these two sides, which are not parallel to each other, they are equal. And you have a right trapezium. In a right trapezium, you have two right angles. Okay, two 90 degrees angles. Okay, in a right trapezium. So a few things that you need to know about an isosceles trapezium. An isosceles trapezium has got one line of symmetry. Okay, this line is a line of symmetry. You can fold this trapezium about this line. You are going to have this part exactly on top of this part. So an isosceles trapezium has got one line of symmetry. Not this, not this, not this. Only an isosceles trapezium. And an isosceles trapezium has got two diagonals of equal length. This diagonal and this diagonal, they are equal. But in this, the diagonals are not equal. Okay, in this we said the diagonals are of an equal length. Okay, and an isosceles trapezium is cyclic. Okay, we are going to see this in 7 of 25. And another thing that you need to know about an isosceles trapezium, the base angles. Okay, the upper base angles, they are equal to each other. And the lower base angles are equal to each other. Okay, so can you see this side is parallel to this side? Now you have your U shape. Remember, the U shape, co-interior angles. Okay, so this angle plus this angle, you must have 180 degrees because this side is parallel to this side. So you have co-interior angles. Okay, your mag, the U shape, even this side. Okay, you have your U shape, this angle plus this angle. You are going to have co-interior angles because this side is parallel to this side. So you have this angle plus this angle. You must have 180 degrees, not this and this, because this side is not parallel to this side. You must have parallel side so that you can have your co-interior angles, which are supplementary. Okay, I hope you know that. So let's move on. Okay, now we are going to see the properties of a rectangle and properties of a parallelogram and properties of a rhombus. Okay, so a rectangle is an equiangular quadrilateral. Equiangular meaning all angles are equal. All angles are equal. This is a right angle, this is a right angle, this is a right angle, and this is a right angle. Okay, equiangular meaning all angles are equal. Okay, and a parallelogram. A parallelogram is a quadrilateral, and a rhombus is an equilateral quadrilateral. Okay, equilateral meaning all sides are equal. Okay, all sides, they are equal to each other. Okay, the four sides are equal to each other. Equilateral meaning all sides are equal. Equiangular meaning all angles are equal. Okay, remember we also have an equilateral triangle. So an equilateral triangle has got all three sides equal to each other. An equilateral quadrilateral, all four sides, they are equal. Okay, let's carry on. The properties of a rectangle. Opposite angles are equal and are all right angles. Okay, opposite angles. Opposite angles. They are equal, right? Opposite angles. They are equal and are all right angles. Okay, they are all 90 degrees. All of them. And for a parallelogram, opposite angles are equal. Okay, this angle is equal to this angle. This angle is also equal to this angle. Okay, opposite angles are equal. And for a rhombus, opposite angles are equal. Okay, this angle is equal to this angle. This angle is equal to this angle. Let's carry on. For a rectangle, opposite sides are parallel and of equal length. Okay, opposite sides, they are parallel and they are of equal length. This side is equal to this side. This side is equal to this side. Okay, opposite sides are parallel and they are of equal length. Okay, and for a rhombus, opposite sides are parallel and of equal length. For a rhombus, the opposite sides are parallel and all four sides are equal to each other. Okay, you can see the difference. The opposite sides are parallel and all four sides are equal to each other. Okay, all four sides, they are equal to each other. Okay, let's carry on. And a rectangle has got two diagonals of equal length. Okay, two diagonals of equal length. This diagonal is equal to this diagonal. Okay, for a parallelogram has got two diagonals of unequal lengths. Okay, has got two diagonals of unequal length for a parallelogram. This diagonal is not equal to this diagonal. This diagonal is longer than this diagonal. You can see that. And for a rhombus has got two diagonals of unequal lengths. Okay, let's carry on. For a rectangle, the diagonals bisect each other. Okay, to bisect means to divide into two equal parts. So this part is equal to this part. This part is also equal to this part. Okay, you can see that. Let me get my highlighter. So this is the same as this. Okay, and this is the same as this. This is to bisect. They divide each other into two equal parts. Okay, so the diagonals of a rectangle bisect each other. Okay, let's carry on. For a parallelogram, the diagonals bisect each other. Okay, you can see that. For a rhombus, the diagonals bisect each other at 90 degrees. They bisect each other at 90 degrees. You can see that. Let me get my highlighter. So this is the same as this. Okay, and this is the same as this. They bisect each other. Remember, the diagonals are of unequal lengths. They bisect at 90 degrees. So the angle there is 90 degrees. Okay, you can see the similarities and the differences. Okay, let's carry on. For a rectangle, each diagonal divide the rectangle into two congruent right triangles. Okay, let me show you. So this diagonal gives you this right triangle, and it also gives you this right triangle. You can see the right angle there, the right angle. This is a right triangle, this is a right triangle. They are congruent using the congruence property, side, side, side. Okay, you can also check this diagonal. Let me show you that. This diagonal also gives you two right triangles. Okay, you have your right angle there. Okay, congruence property, side, side, side. Okay, this side is the same as this side. Okay, this side is the same as this side, and they have a common side, right? So congruence property, side, side, side. Okay, let's carry on. Now for a parallelogram, each diagonal divide the parallelogram into two congruent triangles. So one diagonal gives you two obtuse triangles, and the other diagonal gives you two acute triangles. Let's carry on. For a rhombus, each diagonal divide the rhombus into two congruent isosceles triangles. Now for a rectangle, the sum of adjacent angles is equal to 180 degrees. Even for a parallelogram, the sum of adjacent angles is equal to 180 degrees. Even for a rhombus, the sum of adjacent angles is equal to 180 degrees. Okay, let's see that. Let me get my highlighter. So, can you see this angle plus this angle? You are going to have 180 degrees. Adjacent means next to each other. This angle plus this angle, you are going to have 180 degrees. You can see your U shape. Can you see the U shape? Okay, the U shape or the mag. This side is parallel to this side. Okay, you can also see this, the U shape. This side is parallel to this side. This angle plus this angle, you are going to have 180 degrees. Okay, adjacent angles. Adjacent means next to each other. You can also use this and this. Okay, this angle plus this angle, you are going to have 180 degrees. Okay, this side is parallel to this side. You can also use this. This side is parallel to this side. This angle plus this angle, you are going to have 180 degrees because this side is parallel to this side. So adjacent angles are supplementary. Okay, adjacent angles are supplementary. You can check for a parallelogram. You have your U shape. Can you see the U shape? This side is parallel to this side. So this angle plus this angle, you're going to have 180 degrees. Okay, the two angles are supplementary. Okay, adjacent angles means angles next to each other. Okay, you can also check this. This side is parallel to this side. So this angle plus this angle, you're going to have 180 degrees. Okay, you can go around, you're going to see that. Let's carry on. For a rectangle has got two lines of symmetry. Okay, a rectangle has got two lines of symmetry. Let me show you. The first one, you have it there. So if I can fold this rectangle about this line, I'm going to have this part exactly on top of this part. Okay, so this is symmetry. This is one line and another line, this one. Okay, I'm going to have this part on top of this part if I fold about this line. Okay, so two lines of symmetry for a rectangle. Okay, not this, because if I fold this part about this line, it's not going to lie exactly on top of this. So this is not a line of symmetry, and this is also not a line of symmetry. Okay, only two lines, this one and this. Okay, two lines. Now, for a parallelogram, we don't have a line of symmetry. Okay, a parallelogram has got no line of symmetry. No line of symmetry. You can't have it. This, if you try to fold this parallelogram about this line, this part, it's not going to lie exactly on top of this part. You're going to have something like this. Let me try to show you. This is going to be something like this. I don't know if I can get it right. Okay, I hope you understand what I'm trying to do. You can try. You are not going to have a line of symmetry. For a rhombus has got two lines of symmetry, which are its diagonals. Okay, for a rhombus, if I fold the rhombus about this diagonal, this part will be exactly on top of this part. Okay, if I use this diagonal, can you see? Let me get my highlighter. If I use this diagonal, this part will be exactly on top of this part. Okay, so a rhombus has got two lines of symmetry, which are its diagonals. Okay, this and this. Okay, two lines of symmetry for a rhombus, two lines of symmetry for a rectangle, no line of symmetry for a parallelogram. Now, for a rectangle, the diagonals do not bisect the opposite angles. You can see this is not equal to this. This angle is not equal to this. This angle is not equal to this. This angle is not equal to this. Okay, do not bisect. You can have your alternating angles. Let me show you. I have this line is parallel to this line. I can do this. Alternating. So this angle is the same as this angle. Okay, alternating angles. Okay, or you can do this. This side is parallel to this side. So this angle is also equal to this angle. Alternating angles. Okay, or you can do this. this side is parallel to this side. So this angle is equal to this angle. Okay, alternating angles. Okay, you can play around to get your alternating angles, but you have to know that the diagonals do not bisect the opposite angles. Okay, for a parallelogram, the diagonals do not bisect the opposite angles. Okay, so this angle is not equal to this angle, and this angle is not equal to this angle. This angle is not equal to this angle. This angle is not equal to this angle. Okay, for a rhombus, each diagonal bisect the opposite angles. Okay, you can see the difference. You can see that this angle is equal to this angle. 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 So a rectangle and a rhombus is a special case of a parallelogram because of the similarities. They all have opposite sides parallel to each other. Now, to calculate the area of a rectangle, if we call this a length and we call this the width, the area is equal to the length times the width. Okay, you know this. And for the area of a parallelogram, if we call this B and you have your height h, the height is perpendicular to this side or perpendicular to this side. The area is going to be B times h. And for the area of a rhombus, if we call this diagonal 1, okay, D1, and diagonal 2, D2, the area is going to be 1 over 2 times diagonal 1 times diagonal 2. You can also calculate the area of a rhombus. Let's call this B or this B, okay, B, and you have your height, which is perpendicular, okay, so the area is going to be B times the height, okay. I hope you can see that. B times the height. Let me do this. Okay. B times the height. So you can calculate the area of a rhombus like this or like this. Or you can also calculate the area of a rhombus using trigonometry. Okay, I'm not going to cover that in this video. And I also have this table so that you can compare the similarities and differences between a rhombus and a square. Okay, you can pause the video and read. You are going to see the similarities and differences between a rhombus and a square. A rhombus sometimes is referred to as a tilted square. Okay, for the area of a square, you know how to find it. If I call this S, the area is going to be S times S, okay, or S square. Okay, we are done with part 6 of 25. Please check for part 7 of 25.